This is the EdExcel A-Level Further Maths Paper 1 covering the core pure content, and it's from the 2023 series. Question number 1. The cubic equation x cubed subtract 7x squared subtract 12x plus 6 equals 0 has roots alpha, beta and gamma. Without solving the equation, we have to determine a cubic equation whose roots are alpha plus 2, beta plus 2 and gamma plus 2, giving an answer in the form w cubed plus pw squared plus qw plus r equals 0, where p, q and r are integers to be found. To begin with, we have our cubic equation x cubed subtract 7x squared subtract 12x plus 6 equals 0. Now, each of our new roots, alpha plus 2, beta plus 2 and gamma plus 2, are of the form w equals x plus 2. Now, what we need to do is rearrange for x and then substitute back into our original equation to find a new equation. So if we rearrange for x, you will find x to equal w subtract 2. What we now need to do is replace the x with w subtract 2. And if we do that, we end up with w subtract 2 cubed subtract 7 multiplied by w subtract 2 squared subtract 12 lots of w subtract 2 plus 6 equals 0. So if we expand, well, we have w subtract 2 cubed, that's given by w cubed subtract 6w squared plus 12w subtract 8, and then we subtract 7 multiplied by w subtract 2 squared, so we have negative 7 multiplied by w squared subtract 4w plus 4, and then we have negative 12 multiplied by w subtract 2, which is negative 12w plus 24. We still have this plus 6, and this is equal to 0. So, we have w cubed subtract 6w squared plus 12w subtract 8, and then if I multiply this negative 7 into this bracket, we end up with negative 7w squared plus 28w subtract 28, and then we still have the negative 12w plus 24 plus 6, and this is equal to 0. And if we collect like terms and simplify, you will find w cubed subtract 13w squared plus 28w subtract 6 equals 0. This cubic has roots alpha plus 2, beta plus 2 and gamma plus 2, and what we can see then, the value of p is negative 13, the value of q is 28, the value of r is negative 6. Question 2, part A. We have to write x squared plus 4x subtract 5 in the form x plus p squared plus q, where p and q are integers. To begin with, we have x squared plus 4x subtract 5, and what we need to do is complete the square. And if we complete the square, well, we have x plus 2 squared subtract the square of 2 subtract 5, and we can simplify this to x plus 2 squared subtract 4 subtract 5, which simplifies to x plus 2 squared subtract 9. Part B. Hence use a standard integral from the formula book to find the integral of 1 over the square root of x squared plus 4x subtract 5 with respect to x. So, for part B, we have our integral 1 over the square root of x squared plus 4x subtract 5 with respect to x. We can replace the x squared plus 4x subtract 5 with what we've just worked out in part A. We can replace this quadratic with x plus 2 squared subtract 9, as we see here. Now, the 9 we can replace with 3 squared, leaving us with the integral of 1 over the square root of x plus 2 squared subtract 3 squared. Now if we go to the formula book, the integral is of the form 1 over the square root of x squared subtract a squared and the result of that is the inverse hyperbolic cosine of x over a, or the natural log of x plus the square root of x squared subtract a squared. And so the result of this integration is the same as the inverse hyperbolic cosine of x plus 2 over 3 plus c, or the natural log of x plus 2 plus the square root of x plus 2 squared subtract 3 squared plus c. Part C, we have to determine the mean value of the function f of x equals 1 over the square root of x squared plus 4x subtract 5, where x is in between 3 and 13, giving an answer in the form a times the natural log of b, where a and b are constants in simplest form. For part C, the mean value, that's given by 1 over 13 subtract 3, and then we multiply this by the result of our integration. We have 1 over 13 subtract 3 multiplied by the natural log of x plus 2 plus the square root of x plus 2 squared subtract 3 squared. And then we need to evaluate this between 3 and 13. So then 1 over 13 subtract 3, that's a tenth. And then if we substitute for our upper limit, we have the natural log of 13 plus 2 plus the square root of 13 plus 2 squared subtract 3 squared. And then we subtract our lower limit, we subtract the natural log of 3 plus 2 plus the square root of 3 plus 2 squared subtract 3 squared. So if we attempt to work this out, well, for the upper limit, we've got the natural log of 15 plus the square root of 216. For the lower limit, we've got the natural log of 5 plus root 16. And if we work all of this out by using the subtraction law of logs, we end up with 1/10 multiplied by the natural log of 5 plus 2 root 6 over 3. So the mean value is 1/10 times the natural log of 5 plus 2 root 6 over 3. Question number 3. Z1 is equal to negative 4 plus 4i. Part A, we have to express Z1 in the form r multiplied by cos theta plus I sin theta, where r is a real number, r is greater than 0, and theta is in between 0 and 2 pi. So for part A, we can begin by working out the value of r, that's the modulus of z, which is equal to negative 4 squared plus 4 squared, which is equal to 4 root 2. We can now work out the argument of z1, that's equal to the inverse tan of 4 over negative 4, but then we add on pi because we want our solution to be in between 0 and 2 pi. And if we work this out, we get 3 pi over 4. We now know the argument, we also know the modulus, so what we can do is express z1 in the required form. z1 is equal to 4 root 2 multiplied by the cosine of 3 pi over 4 plus I sine of 3 pi over 4. Z2 is equal to 3 multiplied by the cosine of 17 pi over 12 plus I sine of 17 pi over 12. Part B, we have to determine in the form a plus ib, where a and b are exact real numbers, z1 over z2, and then z2 to the 4. First of all, z2, that's equal to 3 multiplied by the cosine of 17 pi over 12 plus I sine of 17 pi over 12. And we know what z1 is. So for us to work out what z1 over z2 is, we can begin by working out the modulus of z1 over z2, and that's equal to 4 root 2 over 3. We can now work out the argument of z1 over z2. What we have to do is subtract the arguments. So we have 3 pi over 4 subtract 17 pi over 12, and if we work this out, we get negative 2 pi over 3. We now know the modulus, we now know the argument. So z1 over z2, that's equal to 4 root 2 over 3, and then we multiply this by the cosine of negative 2 pi over 3, and then we add I sine of negative 2 pi over 3. So we have 4 root 2 over 3, and if I work out what this complex number is, I have the cosine of negative 2 pi over 3 plus I multiplied by the sine of negative 2 pi over 3. I'm working this out. We multiply 4 root 2 over 3 by negative 1/2, subtract I multiplied by root 3 over 2. And if I expand the brackets and simplify, you will find z1 over z2 to equal negative 2 root 2 over 3, subtract I multiplied by 2 root 6 over 3. Next, for us to work out z2 to the 4, well, I know what z2 is. That's 3 multiplied by the cosine of 17 pi over 12 plus I sine of 17 pi over 12. I need to raise all of this to the power of 4. And for me to simplify all this, I can use De Moivre's theorem. For that, we have the 3 being raised to the 4th power, and bringing this power into the argument, we have the cosine of 4 times 17 pi over 12, and then we add on I sine of 4 times 17 pi over 12. So 3 to the 4, that's 81, and then 4 times by 17 pi over 12, that's 17 pi over 3. So we have 81 being multiplied by the cosine of 17 pi over 3 plus I sine of 17 pi over 3. And if we work out what the cosine of 17 pi over 3 is, and what the sine of 17 pi over 3 is, using our calculator, we have the cosine of 17 pi over 3, and then we add on I multiplied by the sine of 17 pi over 3, and it turns out we get 1/2 subtract root 3 over 2 I. So we multiply 81 by 1/2 subtract I multiplied by root 3 over 2, and if I multiply this out, we get 81 over 2 subtract I times 81 root 3 over 2. Part C, show on a single Argand diagram the complex numbers z1, z2 and z1 over z2, and in the region defined by z belonging to a set of complex numbers where the mod of z minus z1 is less than mod of z minus z2. Now, what we clearly need is the perpendicular bisector of these lines. So here you can see we have z1 plotted, that's negative 4 plus 4i. We have z2 plotted, that's 3 times by the cosine of 17 pi over 12 plus I sine of 17 pi over 12. And then we have z1 over z2, which is equal to negative 2 root 2 over 3, subtract I times 2 root 6 over 3. Now, we need the perpendicular bisector. So, I create a line which joins Z1 and Z2, and then I find the midpoint, and then I draw the perpendicular bisector as we see shown shaded here. And therefore, this region would represent the mod of Z minus Z1 being less than the mod of Z minus Z2. We need a dashed line because we have a strong inequality. Question number 4. Prove by induction that for n belonging to a set of natural numbers, 1, negative 2, 0, 1 to the n is equal to 1, negative 2n, 0, 1. Ultimately, what we want to show is 1, negative 2, 0, 1 to the k plus 1 is equal to 1, negative 2 lots of k plus 1, 0, 1. In other words, we want to replace the n with k plus 1. This is ultimately what we want to show. So, to begin with, let's take a look at the left hand side when n is equal to 1. When n is equal to 1, we have 1, negative 2, 0, 1 to the 1. That's going to equal 1, negative 2, 0, 1. If we take a look at the right hand side when n is equal to 1, we have 1, negative 2 lots of 1, 0, 1, which it turns out is 1, negative 2, 0, 1. So what we can see then, when n is equal to 1, the left hand side and the right hand side are equal, so the result is true for n equals 1. Our next step is to assume that this result is true for n equals k. So if we assume that the result is true for n equals k, we replace the n with k. In other words, we've got 1, negative 2, 0, 1 to the k equals 1, negative 2k, 0, 1. Our next step is to see what happens when n is equal to k plus 1. So we have 1, negative 2, 0, 1 to the k plus 1, and using the laws of indices, this is equal to 1, negative 2, 0, 1 to the k multiplied by 1, negative 2, 0, 1. And at this point, we can use our assumption step, and using that we've got 1, negative 2k, 0, 1, and 1, negative 2, 0, 1 to the 1 is just 1, negative 2, 0, 1. And at this point, we need to multiply the matrices together. So, we have 1 times by 1 plus negative 2k times by 0, that's just 1. Then we've got 1 times by negative 2 plus negative 2k multiplied by 1, so that's negative 2 subtract 2k. Then we have 0 times by 1 plus 1 times by 0, that's just 0. And then we have 0 multiplied by negative 2 plus 1 times by 1, which is 1. And if we take a look at what we have here and compare it with what we mentioned earlier, that is the result we want to show, where we have 1, negative 2 lots of k plus 1, 0, 1. What we can then do is factorize out a negative 2 here, leaving us with 1, negative 2 lots of k plus 1, 0, 1. And that's exactly what we wanted to show. So now, we see that the statement is true for n equals 1, and if it's true for n equals k, then it's true for n equals k plus 1. We've just shown that by induction, which means the result is true for n belonging to a set of natural numbers. Question number 5, the line L1 has equation x plus 5 over 1 equals y plus 4 over negative 3 equals z subtract 3 over 5. The plane pi1 has equation 2x plus 3y subtract 2z equals 6. We have to find the point of intersection of L1 and pi1. To begin with, for part A, we have our equation of line L1, x plus 5 over 1 equals y plus 4 over negative 3 equals z subtract 3 over 5. And if we go to the formula book, that is a standard equation of the straight line through some point A with direction vector B. And notice how it's equal to lambda, which means that this equation is all equal to lambda. I can write this in column notation. I can also write this line L1 as r equals x, y, z equals negative 5, negative 4, 3 plus lambda multiplied by 1, negative 3, 5. Now I've got this plane pi1. That's given by 2x plus 3y subtract 2z equals 6. What I can do is find out where the line L1 and pi1 intersect by replacing x with negative 5 plus lambda, y with negative 4 subtract 3 lambda, and z with 3 plus 5 lambda. So I've got 2 multiplied by negative 5 plus lambda, plus 3 multiplied by negative 4 subtract 3 lambda, subtract 2 multiplied by 3 plus 5 lambda, that's equal to 6. And if I expand the brackets, we find negative 10 plus 2 lambda, subtract 12, subtract 9 lambda, subtract 6, subtract 10 lambda equals 6. Negative 17 lambda equals 34, which means lambda equals negative 2. And knowing that lambda equals negative 2, I can substitute that back in here to find the point of intersection. So I've got x, y, z, some general point, that's equal to negative 5, 4, 3, subtract 2 multiplied by 1, negative 3, 5, and it turns out we get negative 7 to negative 7. And so if that's the case, the point of intersection is negative 7 to negative 7. The line L2 is a reflection of the line L1 in the plane pi1. For part B, we have to show that a vector equation for the line L2 is r equals negative 7 to negative 7 plus mu multiplied by 10, 6, 2. Well, here is a diagram of the plane pi1. It's got equation 2x plus 3y subtract 2z equals 6. We've got the line L1 and we've got the line L2, which is a reflection of L1 in this plane pi, and then we've got the normal to the plane pi with equation L3. From the coefficients of x, y, and z, we can find the direction vector of the normal vector. That's given by 2, 3, negative 2. They are the coefficients of x, y, and z. What we also know is the line L1 is given by r equals negative 5, negative 4, 3 plus lambda multiplied by vector 1, negative 3, 5. And what we also know is the point negative 7 to negative 7 is where the line L1 intersects the plane pi. Now, if we think about this point of negative 5, negative 4, negative 3, this will lie on L1. So we have negative 5, negative 4, 3, which lies on L1. And that's shown here. So what we can now do is find out the equation of L3. We know the direction vector, we know the point it passes through. So the line L3, normal to pi1, is given by r equals negative 5, negative 4, 3, plus t multiplied by the direction vector 2, 3, negative 2. And we can add this to our diagram. What we can now do is find out where L3 meets the plane pi 1, and that's this point here. So we can find out what this point is, and we can do that by substituting in the x, y and z into the plane pi 1. So we have 2 multiplied by x. Now x here is -5 plus 2t. Then we have plus 3y. So we add on 3 multiplied by -4 plus 3t. And then we have -2z. So we have -2 multiplied by 3 plus -2t. And that's going to equal the 6. So if I expand the brackets, well, I've got -10 plus 4t, subtract 12 plus 9t, subtract 6 plus 4t equals 6. So 17t equals 34, which means t equals 2. So the line L3 meets the point of intersection with pi 1 when t equals 2. And what I can do is find out what this point over here is, where L2 and L3 intersect, and that will be double the 2, because from here to here is t, so double that value will tell us then that the line L3 meets the line L2 when t equals 4. That's double the 2. So we can actually find out what that point is. Because we know what t is, that's equal to 4. We have -5, -4, 3, plus 4 multiplied by 2, 3, -2, which is 3, 8, -5. Which means 3, 8, -5 lies on L2. And if we show that on the diagram, that's shown here. So we know that this point lies on L2. And what we can now do then is find the direction vector of L2. We've got this point here, -7 to -7, which lies on L2. And then we've also got this point here, 3, 8, -5, which also lies on L2. So if I find the direction vector, I've got 3, 8, -5, subtract -7 to -7. I'm working that out. The direction vector is given by 10, 6, 2, which is the same as 2 multiplied by 5, 3, 1. And therefore, the line L2 is given by -7 to -7 plus mu lots of 5, 3, 1. I could have used the 10, 6, 2 if I wanted to, and using the 10, 6, 2 instead of the 5, 3, 1 will still be the same equation of the line, because I've factored out that mu. So the line L2 is given by -7 to -7 plus mu multiplied by 5, 3, 1. The plane pi 2 contains the line L1 and the line L2. For part C, we have to determine a vector equation for the line of intersection of pi 1 and pi 2. So for part C, we require a normal vector to determine pi 2, and we can find this by finding the cross product of the direction vectors of L1 and L2. So here we have the direction vector of L1, 1, -3, 5, and here we've got the direction vector of L2, 5, 3, 1. So to find the cross product, well, we have our I, j and k. We've got 5, 3, 1 cross with 1, -3, 5. So let's work this out using our calculator. We need to define vector A and vector B. So if we press F3 and F6 to switch this to vector mode, if we define vector A, we have a 3 by 1. We have 5, 3, 1. What we also need to do is define vector B. We have 3 rows, 1 column. We have 1, -3, 5. So now we need to calculate with all this. So if I press options, then go to matrix/vector, press F6, and press F6 again, we want the cross product. So press F3, we want the cross product between vector A, and then press comma, and vector B. And if we work this out, you can see we have 18, -24, -18. Which means then, the normal vector is 3, -4, -3. All we do is multiply this by 6 to get this vector here. And if you recall from the formula book, the general Cartesian form of a plane is n1x plus n2y plus n3z equals -d. And that's by subtracting d from both sides, where n1, n2 and n3 are the coefficients of I, j and k of the normal vector. Which means then, pi2 is given by 3x subtract 4y subtract 3z equals d. Now the point -7 to -7 would lie in pi2. The reason for that is, well, if we go back to the question, we know that the plane pi2 contains the line L1 and L2, and -7 to -7 satisfies L1 and L2, which is why -7 to -7 lies on pi2. Which means then, we can substitute this point in to pi2 to find out what d is. So, d is equal to 3 multiplied by -7, subtract 4 multiplied by 2, subtract 3 multiplied by -7, and it turns out d is equal to -8, which means pi2 is given by 3x subtract 4y subtract 3z equals -8. So we have pi1 and pi2, and what we need to do is find out the line where they intersect, and that is shown in this green line. And so therefore what we can do is find the direction vector of this line, and that's recognizing we need the normal vector to pi1 and pi2, and that will be defined by the cross product of 3, -4, -3 and 2, 3, -2, which is the normal vectors of pi1 and pi2. So we need to work out this result here. So similar to before, let's go to the matrix/vector option. Let's define matrix C, 3 rows, 1 column. We have 3, -4, -3. And let's define matrix D, 3 rows, 1 column. We have 2, 3, -2. And if we go to options and press F2, then F6, then F6 again, we want the cross product between vector C and vector D. I'm working this out. We have 7, 0, 17. as we see here. So now that we know the direction vector, what we now need to do is find out some point on this line. And the easiest ways to do that is, if we think about what pi 1 is, we know from earlier that pi 1 is 2x plus 3y subtract 2z equals 6. And if we think about what pi 2 is, where we had the 3x subtract 4y subtract 3z equals -8, we can find a general point on the line by setting z equal to 0. And so if we set z equals 0, considering what we have for pi 1, when z equals 0, well, we have 2x plus 3y equals 6, as we see here. And if we set z equals 0 here, we've got the 3x subtract 4y equals -8, as we see here. So now what we need to do is find out the value of x and the value of y. We know the value of z is 0. So for that, if we go to the menu, then go to the equation sub-menu, we have a simultaneous equation with two unknowns. We've got 2x plus 3y equals 6. We also have 3x subtract 4y equals -8. So what you will find is we have x equals 0 and y equals 2. So we've got the point 0, 2, 0, which lie on this line. And if that's the case, then the line of intersection has equation r equals 0, 2, 0 plus some parameter s multiplied by 1, 0, 1, and I've factored out the 17 from here. So this line, which is what we are required to find, has equation r equals 0, 2, 0 plus s multiplied by 1, 0, 1. The plane pi 3 has equation r dot with 1, 1a equals b, where a and b are constants. Given that the planes pi 1, pi 2 and pi 3 form a sheaf, for part D we have to determine the value of a and the value of b. Now if we consider the diagram which we discussed previously, we've got pi 2 and pi 1 forming a sheaf, and at a particular point there is consistency. In other words, the equations are all the same because they form a sheaf. So for part D, we've got pi 1, which is equal to 2x plus 3y subtract 2z equals 6. We'll call this equation 1. We've got pi 2, that's given by 3x subtract 4y subtract 3z equals -8. We'll call this equation 2. And then for pi 3, I'm going to write that in Cartesian form. That's x plus y plus az equals b. We'll call this equation 3. Now we know from that diagram which I've just shown, pi 1 and pi 2 form part of a sheaf with pi 3. Which means at a particular point the equations are the same. Now if we take a look at how we could get the same equations from pi 1 and pi 2, hopefully you will spot they are the same when y equals 2. And the reason for that is because we've got 2x plus 6 subtract 2z equals 6. So the 6's cancel. And then here we would have 3x subtract 8 subtract 3z equals -8. And the -8's cancel. So equation 1 becomes 2x plus 6 subtract 2z equals 6. And because the 6's cancel, we would have 2x subtract 2z equals 0, in which case x is equal to z. And similarly, for equation 2, we would have 3x subtract 8 subtract 3z equals negative 8. The negatives 8 cancel. We are left with 3x subtract 3z equals 0, in which case x is equal to z. So now, bearing that in mind, if we think about equation 3, when y equals 2, we would have, for equation 3, x plus 2 plus az equals b. But as we know that x is equal to z because these three planes form a sheaf, we would have z plus 2 plus az equals b. In other words, I've replaced the x with z. We now can find a and b with this equation. I can rewrite this as 1 plus a lots of z plus 2 equals b. Straight away, if we compare the number terms, you can see straight away b is equal to 2. And if we compare the z terms, on the left hand side we have 1 plus a of them, on the right hand side we have 0 of them, meaning 1 plus a is equal to 0, in which case a is equal to negative 1. So we have a equals negative 1 and b equals 2. Question number 6. Water is flowing into and out of a large tank. Initially the tank contains 10 litres of water. The rate of flow of the water is modelled so that there are v litres of water in the tank at time t minutes after the water begins to flow. Water enters the tank at a rate of 3 subtract 4 over 1 plus e to the 0.8 t litres per minute, and water leaves the tank at a rate proportional to the volume of water remaining in the tank. Given that when t equals 0, the volume of water in the tank is decreasing at a rate of 3 litres per minute, we have to use the model to show that for part A, the volume of water in the tank at time t satisfies this differential equation dv over dt equals 3 subtract 4 over 1 plus e to the 0.8 t subtract 0.4 v. So for part A, water enters the tank at a rate of 3 subtract 4 over 1 plus e to the 0.8 t litres per minute. And water leaves the tank at a rate of kV litres per minute. The reason we multiply v by some constant is because we know water leaves the tank at a rate proportional to the volume of water remaining in the tank. So we know the rate of water into the tank, we know the rate of water out of the tank, so therefore the overall rate of change, dv over dt, that's given by 3 subtract 4 over 1 plus e to the 0.8 t subtract kv. And what we also know is when t is 0, dv over dt is negative 3 and v equals 10. So we can substitute these into our differential equation, leaving us with 3 subtract 4 over 1 plus e to the 0 subtract kv equals negative 3. And then here we've got 3 subtract 4 over 2, which is just 1. And then knowing that v is 10, we subtract 10 lots of k, and this is equal to negative 3, which means k is equal to 0.4. And knowing that k is 0.4, we can therefore conclude our differential equation given by 3 subtract 4 over 1 plus e to the 0.8 t subtract 0.4v is dv over dt. Part B, we have to determine the derivative with respect to t of the arctangent of e to the 0.4t. Well, if we go to the formula book, the derivative of the arctangent of x is given by 1 over 1 plus x squared. Now instead of us having an x, what we have is an e to the 0.4t, which means we would have to use the chain rule. So therefore, for part B, if we were to differentiate the arctangent of e to the 0.4t, well, what we have is 1 over 1 plus e to the 0.4t squared multiplied by the derivative of e to the 0.4t, which is 0.4e to the 0.4t. And if we simplify this entire result, we end up with 0.4e to the 0.4t over 1 plus e to the 0.8t. Hence, by solving the differential equation from part A for part C, determine an equation for the volume of water in the tank at time t. Give your answer in simplest form as V equals f of t. So, for part C, we begin with our differential equation dv over dt equals 3 subtract 4 over 1 plus e to the 0.8t subtract 0.4v. We need to write this in an integrable form. And if we write this in an integrable form, what we have to consider is the integrating factor in all this. So, we have dv over dt plus 0.4v equals 3 subtract 4 over 1 plus e to the 0.8t. And so, if we attempt to integrate this using the integrating factor to work out our integrating factor to begin with, the integrating factor is given by e to the 0.4 dt, which is equal to e to the 0.4t. Therefore, we have e to the 0.4t multiplied by v, and this is equal to the integral of our integrating factor e to the 0.4t multiplied by what we have on the right hand side, 3 subtract 4 over 1 plus e to the 0.8t, and we're integrating this with respect to t. And don't forget, we add on a constant of integration c. So now if I multiply this e to the 0.4t into the bracket, we end up with the result we see here. Now, for us to integrate what's inside this bracket, well, we have 4e to the 0.4t over 1 plus e to the 0.8t. And if we consider how that's similar to what we found in part B, well, do you notice that the 0.4 is 10 times smaller than the 4, which means the integral of this is 10 times the integral of the arctangent of e to the 0.4t. So therefore, well, the left hand side remains as it is, and on the right hand side we have this 3e to the 0.4t, and then we subtract 10 times the 0.4e to the 0.4t over 1 plus e to the 0.8t. And don't forget, we're integrating this with respect to t. Now integrating the 3e to the 0.4t, we end up with 15e to the 0.4t over 2, and integrating negative 10 times this result, we end up with negative 10 times the arctangent of e to the 0.4t, and then we still have this plus c. So now we also know that when t is 0, v equals 10. And if we substitute that in, we have 10e to the 0 equals 15e to the 0 over 2, subtract 10 times the arctangent of e to the 0 plus c. Which means we've got 10 equals 15 over 2, subtract 5 pi over 2 plus c. And if we solve for c, you will find c to equal 5 multiplied by 1 plus pi over 2. So now that we know what c is, what we can now do is substitute that back into here to find out our particular solution. We have ve to the 0.4t, that's equal to 15e to the 0.4t over 2, subtract 10 times the arctangent of e to the 0.4t, and then we add on 5 multiplied by 1 plus pi over 2. Now we want this in the form of v equals some function of t in simplest form. So what we can do is divide through by e to the 0.4t, and retaining this 2, on the top we would have 15e to the 0.40 subtract 20 times the arctangent of e to the 0.40 plus 5 multiplied by 1 plus pi. And notice the 20 over the 2 gives the 10. And if we simplify this further, what we can do is factorize out a 5 from the top, and inside the bracket we have 3e to the 0.40 subtract 4 times the arctangent of e to the 0.40 plus 1 plus pi, and then we divide all of that by 2e to the 0.40. After 10 minutes, the volume of water in the tank was 8 litres. We have to evaluate the model in light of this information. So, for part D of the question, let's see what happens when t equals 10. When t equals 10, we've got v equals 5 multiplied by 3e to the 4, subtract 4 times the arctangent of e to the 4 plus 1 plus pi over 2e to the 4. Now, if we work all of this out using our calculator, we have 5 multiplied by 3 multiplied by e to the 4, subtract the arctangent of e to the 4 and then we add on 1, and then we add on pi, and then we will divide this by 2 e to the 4. So it turns out we end up with 7.45, etc. So if I work out the percentage error, what I know from the question is the volume of water in the tank was 8 litres. I've just worked out the volume to be 7.405, etc. litres. So if I work out a percentage error, what we have for our percentage error is 7.43, etc. %. Now, because it's a less than 10%, the model is quite good. Question 7. Part A, we have to explain why, for n belonging to a set of natural numbers, the sum from r equals 1 to r equals 2n of negative 1 to the r multiplied by f of r equals the sum from r equals 1 to r equals n of f of 2r subtract f of 2r subtract 1 for any function f of r. Now, the way to think about this problem is to first of all consider this negative 1 to the r. Now, we're considering n belonging to a set of natural numbers, and we're starting off with r equals 1 and we're finishing at 2n. So we go 1, 2, 3, 4, 5, 6, 7, 8, etc. all the way up to 2n. So, let's consider this negative 1 to the r. What happens when r is even? Well, negative 1 to an even power is always 1. That's when r is even. But what happens when r is odd? Well, negative 1 to the r will always equal negative 1. That's when r is odd. So we've got odd numbers and even numbers being used here from r equals 1 to r equals 2n, and we would have the terms being positive and negative being multiplied by f of r. It doesn't matter what f of r is, but we've got positive terms and negative terms being multiplied by f of r. And if that's the case, then what's happening is this sum alternates between from positive and negative terms. Now, if we consider the integers from 1 to 2n, we've got even and odd numbers being used here. So we can split those up as the following. the even numbers we can split into 2r, going from 1 to n, and then the odd numbers we can split those up into 2r subtract 1 from 1 to n, which means that the sum from r equals 1 to r equals 2n of negative 1 to the r multiplied by f of r is equal to the sum from r equals 1 to n of f of 2r subtract f of 2r minus 1. That's again because we're alternating between positive and negative terms, which is why we subtract. Part B used the standard summation formulae to show that for n belonging to a set of natural numbers, the sum from r equals 1 to r equals 2n of r multiplied by negative 1 to the r plus 2r squared equals n multiplied by 2n plus 1 multiplied by 8n squared plus 4n plus 5. So for part B, we have this sum from r equals 1 to r equals 2n of r multiplied by negative 1 to the r plus 2r squared. So this is equal to the sum from r equals 1 to r equals 2n of r multiplied by this result squared. Now if I square negative 1 to the r plus 2r, well, I've got negative 1 to the r squared, which is negative 1 to the 2r, and then I've got 2 times by negative 1 to the r times by 2r, which is 4r multiplied by negative 1 to the r, and then I've got the 2r squared, which is 4r squared. Now, negative 1 to the 2r, that will always equal 1, because the negative 1 is always raised to an even power. So this result is equal to the sum from r equals 1 to r equals 2n of r multiplied by 1 plus 4r multiplied by negative 1 to the r plus 4r squared. Now what we can do is multiply the r by the 1 and the r by the 4r squared to give us the sum from r equals 1 to r equals 2n of 4r cubed plus r. But then I still have the r times by the 4r times by the negative 1 to the r. And that's equal to 4r squared multiplied by negative 1 to the r. So it remains the same. And if I factorize out of 4, I have 4 multiplied by the sum from r equals 1 to r equals 2n of negative 1 to the r multiplied by r squared. And the reason this is important is because, well, if I go back to the question and take a look at what I have in part A, that r squared is what f of r is equal to, and so I can use the result from part A to help me evaluate that. So, evaluating that as necessary, well, this bit will remain the same, the sum from r equals 1 to r equals 2n of 4r cubed plus r, and this bit, I've got plus 4 multiplied by the sum from r equals 1 to r equals n of 2r all squared subtract 2r subtract 1 squared. So, this bit remains the same, and then I add on 4 multiplied by, well, 2r squared, that's going to be 4r squared, and then I subtract the square of 2r minus 1, so I subtract 4r squared, subtract 4r plus 1. And if I multiply this negative 1 into the bracket and simplify, we still have the sum from r equals 1 to r equals 2n of 4r cubed plus r, and then I add on 4 multiplied by the sum from r equals 1 to r equals n of 4r subtract 1. And so, multiplying the 4 into this, we've got the sum from r equals 1 to r equals 2n of 4r cubed plus r, and then I add on the sum from r equals 1 to r equals n of 16r subtract 4. So what we can do at this point is use the summation results, as we see here, particularly the sum from r equals 1 to r equals n of r cubed equaling 1/4 n squared multiplied by n plus 1 all squared. So if I use that, bearing in mind instead of an n we've got a 2n here, we've got 1/2 multiplied by 2n multiplied by 2n plus 1 plus 4, because I've got the 4 here, multiplied by 1/4 times by 2n squared multiplied by 2n plus 1 squared. And then I add on 16 multiplied by 1/2 times by n plus 1. And then I subtract 4n. So let's attempt to simplify this. I've got 1/2 times by 2n, which is just 1n, and then I'm multiplying that by 2n plus 1. And then I've got 4 times by 1/4, which is just 1. So I'm going to be left with 2n all squared multiplied by 2n plus 1 all squared. And then here I've got 16 times by 1/2, which is 8. So I add on 8n multiplied by n plus 1, and then I subtract the 4n. So I've got the n multiplied by the 2n plus the 1. And then here I've got the 2n squared multiplied by the 2n plus 1 squared. And then what I will do is I will factorize out from these two terms a 4n, and inside the bracket what I will be left with is 2n times n plus 1 subtract 1. Of course 4n times by 2n times by n plus 1 gives the 8n times by the n plus 1, and then I've got the 4n times by the negative 1, which gives negative 4n. And so if we simplify this, we still have the n times by the 2n plus 1. Here we've got the 2n squared times by the 2n plus 1 squared, that's shown here, and then we add on 4n times by 2n plus 1. So I've got n times by 2n plus 1. If I factor all that out, inside I've got 1. Then I've got the 4n, and the reason for that is because 2n all squared is 4n squared, and I've already factorized out an n, leaving me with just the 4n, and I multiply that by 2n plus 1, and then I add on 4, because 4 times by n times by 2n plus 1 gives the 4 times by the 2n plus 1. So I've got n times by 2n plus 1 multiplied by 8n squared plus 4n plus 5, and that's the result I wanted to show. Part C, hence evaluate the sum from r equals 14 to r equals 50 of r multiplied by negative 1 to the r plus 2r squared. Now clearly we would have to use the result from part B. So for part C, we've got this sum from r equals 14 to r equals 50. What we ideally want is to start off with r equals 1. So if that's the case, then we've still got this sum to 50, but we start off with r equals 1. But because here we're starting with r equals 14, what we have to do is subtract the first 13 terms, as we see here. Now the problem is, if we consider with what we found in part B, here we have a 2n, meaning we have an even number, but here we've got an odd number. So the way we go about that is to subtract the 13th term and then subtract the sum of the first 12 terms. So we've got the sum from r equals 1 to r equals 50, that remains as it is. Then we subtract the 13th term, and then we subtract the sum of the first 12 terms. Now we have a sum which has an even upper limit, which means we can then use our result with what we found in part B. And notice here we've got a 2n, which means when we sub back into here, we just require n, which means we are required to half the 50 and half the 12. So evaluating the sum from r equals 1 to r equals 50, what we have to do is substitute in 25, as we see here. Then we've got to subtract the 13th term, and then we also have to subtract the sum of the first 12 terms, and that occurs when n is equal to 6, as we see here. So working this out, we've got 25 multiplied by 2 times by 25 plus 1 multiplied by 8 times 25 squared plus 4 times 25 plus 5. So we end up with a value of 6,508,875, and if I work out the 13th term, well, I've got 13 multiplied by, well, here I've got -1 plus 26 and then square it, so that's 25 squared. So I subtract 8,125, and then if I work out 6 multiplied by 13 multiplied by 8 times 6 squared plus 24 plus 5, I then subtract 24,726. I'm working this out, we end up with 6,476,024. Question number 8. A colony of small mammals is being studied. In the study, the mammals are divided into 3 categories. We've got newborns, and newborns are defined from 0 to less than 1 month old. We've got juveniles, defined by 1 to 3 months old, and we've got breeders, who are defined to be over 3 months old. For part A, we have to state one limitation of the model regarding the division into these categories. Part A, the mammals will not go straight from not breeding at the same rate as the adults at 3 months, and there will be a gradual transition. A model for the population of the colony is given by the matrix equation n plus 1, j n plus 1, b n plus 1 equals 0, 0, 2, a, b, 0, 0, 0.48, 0.96 multiplied by the vector nn, jn and bn. A and b are constants, nn, jn and bn are the respective numbers of the mammals in each category n months after the start of the study. At the start of the study, the colony has breeders only, with no newborns or juveniles. According to the model, after 2 months, the number of newborns is 48 and the number of juveniles is 40. We have to determine the number of mammals in the colony at the start of the study and then show that A is equal to 0.8. Now, the first thing we can do is let the number of mammals at the start of the study equal x, because if we think about what we're finding, we have to find the number of mammals in the colony at the start of the study. And what we know is that there are no newborns and that there are no juveniles at the start of the study, but there's only the breeders at the start of the study. So what we can do at this point is define n0, j0 and b0 to equal 0, 0, x. This is just at the start of the study. So if we work with this, what we can now do is find out what we have after 1 month. In other words, we are finding n1, j1 and b1. Now what we need to do here is use this matrix equation. So if I use that matrix equation, n1, j1, b1, that's equal to this matrix 0, 0, 2, a, b, 0, 0, 0.48, 0.96, and I'm going to multiply this matrix by n0, j0 and b0. And so therefore I can find out what n1, j1 and b1 is. And the reason I want to do that is because ultimately I want to find out what we have after 2 months, because I've been given information about the number of newborns and the number of juveniles. So if I work out what this is, I've got this matrix 0, 0, 2, a, b, 0, 0, 0.48 and 0.96, and I already know what n0, j0 and b0 are. That's given by 0, 0, x. So let's multiply this through and work it out. I've got 0 times by 0 plus 0 times by 0 plus 2 times by x. So I've got 2x there. Then I've got a times by 0, b times by 0, and then I've got 0 times by x is 0. And then I've got 0 times by 0 plus 0.48 times 0 plus 0.96 times by x, which is 0.96x. So this is what we have after 1 month. And again, if I use this matrix equation, what I can now do is find out what we have after 2 months. So after 2 months, what we're after is N2, J2, and B2. So that's equal to this 3 by 3 matrix multiplied by N1, J1, and B1. But I already know what N1, J1, and B1 are. I've just worked that out. So I've got this 3 by 3 matrix multiplied by 2x, 0, 0.96. So if I work out what this is, well, I've got 0 times 2x plus 0 times by 0 plus 2 times by 0.96x, which is 1.92x. Then I've got a times by 2x plus b times by 0 plus 0 times by 0.96x, which is 2ax. And then I've got 0 times by 2x, 0.48 times 0, and then 0.96 times 0.96x, which is 0.9216x. So this is what we have after 2 months. Now, I already know as well, after 2 months, the number of newborns is 48 and the number of juveniles is 40. So therefore, I've got 1.92x equals 48, that's the number of newborns. So what I can do now is find out what x is. So I have 48 divided by 1.92, which is 25. So in other words, x is 25. And what I also know, then, if x is 25, we've got 25 mammals at the start of the study. And what I also know then is 2ax is equal to 40. So the number of juveniles is equal to 40 after 2 months. That's why we have 2ax equals 40. And knowing that x is equal to 25, I've got 2 times 25 times x equals 40, in which case you will find a to equal 0.8. And that's what we wanted to show in this question. Part C, we have to determine in terms of B, the inverse of the matrix 0, 0, 2, 0.8 B0, 0, 0.48, 0.96. And notice, this 0.8 is the value of A. So for part C, the first thing we will do is we will let the matrix M equal 0, 0, 2, 0.8 B0, 0, 0.48, 0.96. Our first step is to find the determinant of this matrix M, as we see here. And if I expand along the top row, and the reason I'm doing that is because there's a lot of zeros here, I've got 0 multiplied by the determinant of B0, 0.48, 0.96. Then I subtract 0 multiplied by the matrix 0.8, 0, 0, 0.96. And then I add on 2 multiplied by the determinant of the matrix 0.8 B 0, 0.48. So now we need to work all of this out. Well, what we will be left with is 2 multiplied by the 0.8 times the 0.48, subtract b times by 0, as we see here. And working this out, we end up with 0.768. We've now worked out the determinant of M. Our next step is to find out the matrix of the minors. So we set up our matrix, and what we will do is we'll expand row by row. So if I expand along the first row, the first element is given by the determinant of B0, 0.48, 0.96. Next element, I have the determinant of 0.800, 0.96. And for the next element, I've got the determinant of 0.8 be 0.48. For the next element, I've got the determinant of 0 to 0.48, 0.96. For the next element, I've got the determinant of 0 to 0.96. For the next one, I've got the determinant of 0.48. For the next one, I've got 0 to be 0. For the next one, I've got 0 to 0.80. And for the next one, I've got 0.8 and b. So now that I've got all this, what I can do is actually work out what that matrix is going to be. So I've got b times by 0.96 subtract 0, which is 0.96b. Here I've got 0.8 times by 0.96 subtract 0, which is 0.768. Here I've got 0.8 times 0.48 subtract 0b, which is 0.384. Here I've got 0 subtract 2 times 0.48, which is 0.96. Here I've got 0 subtract 0, which is just 0. Here I've got 0 subtract 0, which is just 0. Here I've got 0 subtract 2b. Here I've got 0 subtract 2 times 0.8, which is minus 1.6. And here I've got 0 subtract 0, which is just 0. So now that I've worked out the matrix of the minors, what I can now do is find out the matrix of the cofactors. And what we do here is we alternate the signs. So we have plus 0.96b, negative 0.768, positive 0.384, negative minus 0.96, positive 0, negative 0, positive negative 2b, negative minus 1.6, positive 0. So the matrix of the cofactors is given by 0.96b, negative 0.768, 0.384, 0.96, 0, 0, negative 2b, 1.6, 0. So now that I've found the matrix of the cofactors, what I can now do is transpose this, and for that we swap the rows and columns, leaving us with 0.96b, 0.96, negative 2b, negative 0.768, 1.6, 0.384, 0, and 0. So here is the transpose of the matrix, and what we can now do is find the inverse. The inverse is equal to 1 over the determinant, as we see here, multiplied by our transpose matrix, as we see here. And if I multiply the 1 over the 0.768 into this matrix, we end up with the inverse of our matrix M equaling 1.25b, 1.25, negative 2.6442b, negative 1, 0, 2.80333, 0.5, 0, 0. So that's the inverse of our matrix. Given that the model predicts approximately 1015 mammals in total at the start of a particular month, and approximately 596 newborns, 464 juveniles, and 437 breeders at the start of the next month, we have to determine the value of B, giving an answer to 2 decimal places. So for part A, we've got this matrix which represents the number of newborns, the number of juveniles, and the number of breeders in a particular month. And what that's equal to is our matrix 0, 0, 2, 0.8b0, 0, 0.48, 0.96, multiplied by the number of juveniles in that previous month, the number of newborns in that previous month, and the number of breeders in that previous month. And I know that this matrix is equal to 1015. So what I mean by that is n lambda, j lambda, and b lambda is equal to 1015. Now, for me to find out what n lambda, j lambda, and b lambda are, what I need to do is find that out by multiplying this matrix by the inverse of this matrix. So n lambda, j lambda, and b lambda, that's equal to the inverse of this 3 by 3 multiplied by 596, 464, 437. But I've already worked out what the inverse of this matrix is over here. So I need to multiply this 3 by 3 matrix by this vector 596, 464, 437. And if I do that, I've got 1.25b times 596, 1.25 times 464, negative 2.6042b multiplied by 437, and then continuing to work all that out, we end up with this matrix 580 subtract 393.035b. Then I've got the negative 1 times 596 plus 0 times by the 464 plus the 2.80333 times by the 437, which gives the 314.415, and I've got the 0.5 times the 596 plus 0 times 464 plus 0 times 437 gives 298. So I know that this total is the amount we have, we go back to the question, at the start of a particular month. So if I work all this out, I've got the 580 subtract 393.035b. I add that to the 314.415 and add that to the 298. This is all equal to 1015. And knowing that, we can therefore conclude b is equal to 0.45, and that's given to 2 decimal places. It is decided to monitor the number of newborn males and females as part of the study. Assuming that 42% of newborns are male, you have to refine the matrix equation for the model to reflect this information. Giving a reason for your answer, there's no need to estimate any unknown values for the refined model, but any known values should be made clear. So the way we think about this is, well, here is our current matrix. We've got n plus 1, j n plus 1, b n plus 1 equals 0, 0, 2, 0.8, 0.45, 0, 0, 0.48, 0.96 multiplied by nn, jn, bn. But what's happening is we're now splitting this n up into males and females. So because we're splitting the newborns into males and females, we can have a 4 by 4 matrix shown here. We've got newborn males n plus 1, newborn females n plus 1, juveniles n plus 1, and breeders n plus 1 equals some 4 by 4 matrix. We're going to determine this 4 by 4 matrix multiplied by newborn males n, newborn females n, juveniles n, and bn. Now this 0 and this 0, those are going to stay the same. And the reason for that is we've got the 0 times by the newborns, but this newborns is split up into 2 parts, 42% male and 58% female. But 42% of the 0 is 0, and 58% of the 0, which is female, 0. Then we've got this 0, which corresponds to the juvenile, and that remains as it is. But then this 2, if we think about males, what we have is the 42% of the 2. So if I work out what this is, I've got 0.84. So if I expand my first equation, newborn males n plus 1 is equal to 0n males 0n females plus 0j n plus 0.84 bn. Whereas before we had, in general, newborns n plus 1 equals 0n plus 0jn plus 2 bn. Now let's think about the females. We've got the same situation where we'd have the 0 to 0 and the 0, but then we've got 58% of this 2, which will give us the number of newborn females. So I've got to subtract this, which is 1.16. And if I expand along here, I've got newborn females n plus 1 equals 0n males, 0n females plus 0 juveniles n plus 1.16 breeders. So it's as though we've took this top row and we've split it up between males and females, and that's why we get this extra 2 rows from. And we could do the same thing here, but the problem is we don't know how we're splitting up this 0.8 in terms of percentages of males and females for juveniles. So we'll call that C and we'll call the other one D, because here we're going to have C multiplied by newborn males plus D times by newborn females, and then the 0.45 stays the same and the 0 stays the same. And along the final row, we've got 0 newborns, as we have here, 0 times by nn, and obviously nothing's changing there in terms of the breeders. So we have 0 times by n f plus the 0.48 times by jn times by 0.96 bn. So essentially what's happening here is this newborn is being split up further into males and females, which is why we get these 2 extra rows, and the C and D are unknowns. So what we're saying is, before we had newborns equals 2bn, but now we know that it's split up between males and females, which is why number of newborns males and females would require these 2 extra rows. So this is our refined matrix.